Hello, and welcome to my YouTube channel, Mr. Engineer. Today we'll discuss dependent and independent sources in great detail. Sources can be divided into ideal and non-ideal sources. Ideal source is something that stays the way it is for eternity, while on the other hand, non-ideal source, like a 9 volts battery, your phone's battery, a 1.5 volts cell and your watch's cell, will drain out after some time due to its internal resistance. Source can also be divided into voltage source and current source. First, let's discuss voltage source. A voltage source can be either a DC voltage source or an AC voltage source. You can see the symbols for both sources here. Your 9 volts battery is a DC source, and the 200 volts coming in your house socket is an AC source. A current source is represented by an arrow inside a circle. The direction of arrow represents the direction of flow of current. Many students in early semesters find it difficult to imagine a current source. A current source is simply like a voltage source, but rather than constant voltage, it is delivering constant current. You can see the circuit shown here to design the current source. A BJT can be used to do that. Another classification of sources is independent and dependent sources. The sources that we have discussed so far were all independent sources. An independent source is something which is alone, and its value does not depend on anything else. Like a 9 volts battery, while dependent source does not have that luxury. We'll discuss them in great detail, but here I would like you to see the difference in representation of both sources. You can pause the video here for a second or two. We are back, and I hope that you saw that independent sources are represented by circles, while dependent sources are represented by diamond shapes. There are 4 types of dependent sources. Look closely and you'll see that each source has a different equation. The variable on left is the value of that particular source, and the 2 variables on right, one of them represent the scaling factor and the other is the dependent variable on which the value of source depends. V of X for figure A is the dependent variable here, which is the voltage of some element in the circuit. Now, I would like to share that we also name all of these sources. The circuit in figure A is a voltage-controlled voltage source. Can you see why? Okay, let me tell you why we name it like this. I already told you that voltage source is represented by a plus and minus sign inside the diamond shape, while a current source has an arrow inside it. So, now we know that the circuit in the first figure is a voltage source, as it has a plus and minus sign in it. The other thing to notice is that the dependent variable is also voltage, that is V of X, hence, we name it as voltage-controlled voltage source. Now, the next one is current-controlled voltage source. Next is voltage-controlled current source. And the last one is current-controlled current source. I hope you see why we named them like this now. If you don't, just go back to where we started and listen again, because an exercise for you is coming in the next slide. Can you identify the independent and dependent source in this figure? If yes, can you name the dependent source? Kindly try to do that after pausing the video here. Tick tock, and we are back again. Yes, you are right, this is a current-controlled voltage source. Now, repeat the same and try to name this dependent source. Yes, you are right, this is a voltage-controlled voltage source. Try to name this one now. Yes, you are right, this is a voltage-controlled current source. Okay, this is the last one. Try to name this one now. Yes, you are right, this is a current-controlled current source. And voila, we did it. Now you know what are these sources and how to name and identify them. Leave your comments and questions below. If you liked the video, do share it. Subscribe my channel for more videos. And don't forget what we learned today. Have a nice day, buddy.